one of the ways that we were able to reduce bundle size in V4, I think the schedule module is actually a really good example of this. And of course I say that because I'm the one who rewrote it. But one of the ways we were able to reduce bundle size is many modules in effect V3 are what we call like they're pseudo initial encodings, right? And what that means is like you have a set of instructions that you build up, and then you need an interpreter to interpret those instructions. So like effect itself is an initial encoding in V3. In V4, it still is technically an initial encoding, but it's a little bit more of a hybrid, I think. I have to look at the most recent iteration of the runtime, but schedule is a good example of a pseudo initial encoding from V3 that we actually changed to be what's called like a final encoding. And a final encoding, where is my schedule type? Where are you? Schedule variants. Yeah. It's not like a clean mapping, right? Because like there's still aspects of both in these modules. There's still aspects of like initial and final encodings. But if to try to like think about this a little bit more cleanly, you can think of like in V3, many modules were more along the lines of initial encodings, where you'd have a set of instructions, you pass them to an interpreter, that interpreter would interpret said instructions and produce the results, right? And schedule was a good example of this. You created a schedule, and then there was a schedule driver, which actually drove the schedule, right? Iterating through the steps of that schedule. And the driver would call next to go through each subsequent step of the schedule. But in V4, we've tried to get away from that a little bit with a lot of these modules and move more towards an final encoding where the type itself knows how to drive itself, right? So the schedule itself registers steps, and these steps are just pull-based effects that can run. So it's not excuse me. It's not exactly like cleanly saying, oh, we swapped from initial to final encodings, but we did do more of this. And so that allowed us to reduce bundle size in a lot of different places because we were able to not need the driver code for a lot of these data types anymore. So schedule no longer has like a schedule driver because the steps are encoded right onto the schedule itself. And another interesting one is this pull data type that now backs both schedule. So schedule is built on top of this pull data type, and streams are actually totally rewritten to be built, and streams, channels, and syncs are all built on top of this pull data type. Cool. I think sync is as well. And the pull data type is just a generic representation of like a pull effect. So if we look at this, pull is just like an effect that can result with a value. It can fail with either an error or this like special cause.done value, or have some requirements. And so the schedule, if we go back to that, man, where's my step? From step. You'll notice that like we've got this outer effect that registers a function that returns a pull-based effect. And this type is a little bit confusing, but what it enables us to do is have like closures over the pull so that any state we need to maintain can exist in this like closure. And it's like a little bit cleaner or more efficient than what we had to do previously with the driver-based implementation. So a good example of this is like, where can we go? And get past all these like step constructors. Trying to find like a clean example of this. Maybe like add delay. Add delay. Modify delay. All right, so this is not like a great example, but the idea is that like you encode directly onto the data type how it should execute. So the types and the like implementations may look a little bit different, or maybe to some folks might look a little confusing. But the idea is that like you can encode the behavior directly onto the data layer. Probably is actually that's a good point, Mike. We re-encoded layer as well. Maybe layer is a better example. Let me see. So where are we? Where's the layer type? Yeah, so layer is a really good example actually of this is probably a cleaner example of like straight up initial encoding to final encoding transformation. In V3, if I pull up like layer from V3, you're welcome, Mike. Thank you. Sometimes you have good ideas.
You meant Mike always had good ideas.
I meant what I said. If we look at layer from V3, you'll notice we might have to go to the internal implementation here. Yeah, we do. This is another thing is the module structure in V4 is just like a lot cleaner for us as maintainers. But so in V3, you'll notice that the layer data type is a union of all of these different primitive instructions. It's like extend scope, fold, fresh, from effect, scoped, blah, 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 blah. So all of these different instructions are then executed by the build method. So if we scroll down to like const build with scope, this thing delegates to this thing, delegates to make builder. And make builder is the thing that iterates through all of the different instructions and does stuff. So again, this is like layer was in V3 an initial encoding. You have many instructions that then have to be fed to an interpreter to be interpreted. In V4, if we go back to layer in V4, it's a pure initial encoding. Build is a method on the layer itself. There's no intermediate representation. The layer itself encodes how it should be built. So you get rid of all of the code related to the initial encoding. So substantially reduces the amount of code you have to write. And so now if you like look at, I don't know, let's see, maybe there's a combinator here. So here's like an example of like, you know, from build unsafe, you can get access. You can basically encode the build method directly onto the layer that you're producing here, right? You get a build function coming in. You can do all the things you need to do internally, and you encode the behavior onto the type itself. Streams were also refactored in this direction. So if we look at like not internal source,
we could generally say that. Okay.
Go ahead, Mattia.
No, I was saying that we could generally say that a lot of like initial encoding have now been replaced by a function that returns an effect or something like that. So as a final encoding.
Yeah, everything is kind of based on the effect type now, which just by doing that, like all of these ancillary data types, which previously required their own instructions, their own interpreter, et cetera, are now just based on effect. So the amount of code that has to be written to support that data type shrinks substantially because the basis of it is just effect. So channels, for example, are just transform methods that receive the upstream channel or the upstream pull and a scope and do something with it, right? So channels are just a sequence of transform functions that get executed. And you can there's probably good examples in here of like how you can use these methods and build on top of them. But because everything is just basically built on top of effect now, instead of being its own initial encoding and it having to be interpreted and having to write all the code for that, that by itself reduces bundle size. And then, of course, the other reason is that Tim is a machine and rewrote the whole Fiber runtime. He actually made micro from V3 more efficient than it already is, with more features and smaller for V4. So the Fiber runtime from V4, the V4 Fiber runtime was originally based on micro from V3, and then Tim basically made it smaller than that with more features supported and faster and more efficient. And so if you come in here and like look at all of the different stuff going on, I think it's in the effect module here. Yeah. The Fiber implementation you can see is here.
Yeah. Now you can read the Fiber implementation in about like 2 screens. Before you couldn't.
Yeah. The run loop is much easier to reason about now than it was previously.
Yeah.
And I think Maxwell has the rare hat. Indeed, Johannes, I have the rare hat. There are only a select few that have the rare hat.
Now I want the rare hat as well.
Yeah, now you have to get the rare hat.